This video is brought to you by our amazing supporters over at Patreon.
Hey everyone, it's Ben from Board to Bits, and in this video we're going to start implementing our flocking algorithm by building our core flock classes and setting up our scene to populate our initial flock. So I'm just using pretty much the basic 2D project for right now. We are going to be building this in 2D because it's a little bit easier to visualize what's going on in 2D. However, this is also doable in 3D. You would just need to shift anywhere that I'm working with vector 2s, you'd want to shift over to vector 3s, and where I'm using the physics 2D system, you'd be using the normal physics system. But it is definitely doable in either setup, but that is how my project is set up right now. And the other thing I have done is I've imported an image for what's going to be for my flock agents. You can use this, it's available down in the description, there's a link to it below. Or you can use any sprite you'd like. I do like having a sprite that shows some direction on it because that will make it easier to visualize how your flock agents are moving, but you can certainly use one of the default sprites that Unity has within it or another sprite of your choosing. One thing to note, if you are using the sprite that I provided, I did set the pixels per unit to 512 up here in the import settings, so you'll just want to change that and apply it. Okay, with that, we're going to need 3 core scripts to start working with our flock, and that's going to be the flock itself, the flock agent, and the flock behavior. So let's create those in our assets. Do create C# script, create a flock, flock agent, and flock behavior. And we'll start with the flock behavior because for right now it's going to be the very simplest and quickest to get out of the way for us. So our flock behavior is actually going to be an abstract class. We're never going to instantiate a flock behavior. We're going to instantiate things like avoidance or cohesion. It's also going to be a scriptable object. As such, we do not need a start or an update method in here, as it's not going to use those. However, we are going to create an abstract method inside of here that any of our behaviors are going to eventually implement. So that's going to be public abstract. It's going to return a vector 2, and it's going to be called calculate move. And this is going to take into it a few pieces of information. It's going to take one flock agent, which is going to be the agent that we're working with to actually calculate its move. We'll call that agent. It's going to take a list of transforms, and this is going to be called the context. And this is kind of in the basic flock sense, it's going to be what neighbors are around me. We're just going to take their transforms, put them in a list, and pass that into this method. But it could eventually, the reason we're using the transforms and not just say other flock agents is because eventually we might want to use other things, like if there are obstacles in our scene, or boundaries, things like that, we may want to pass those in as well. So we're keeping it a little bit more generic for that purpose. And then finally, we're going to pass in the flock itself, because there may be some situations with certain behaviors that we need some information about the flock itself as well as the agent. So that's all that we need in there. We can just close that with a semicolon. Because it's abstract, we don't actually put a body to this. And so we're just going to save that as is. From here, we're going to open up our flock agent, which is also fairly simple. It has a couple of pieces of information to it. So we'll open that up right in the Solution Explorer here. And so this one is going to be a mono behavior. However, we're going to require a component on it too. The way that we're going to be finding our neighbors is using the physics system to check an overlap circle to see is there anything within a radius around us. And so for that reason, we need to make sure that we have a collider attached to this object. So we're going to say square bracket require component type of collider 2D. We're going to be using circle colliders, but in theory you could use box colliders or some other shape, and so we'll keep that generic there as well. We're going to have a couple of variables. We're going to have our collider 2D, which we're going to call agent collider. Unfortunately, Unity has a kind of a deprecated variable inside of the component class itself, which is called collider, so you can't just call it directly collider, otherwise it creates an override situation and Unity doesn't like it. So we'll just call it agent collider in that case, and then we're going to have a public accessor for this. Public collider 2D I'll call this agent collider as well, but with a capital. And then we're going to say get, and we're going to return agent collider. So that just means now that we will be able to access this collider without ever being able to assign to it. The only time we want to assign to it is when it's actually first starting up. And we're going to do that right now inside of our start method. We're going to say that agent collider will equal get component collider2d. So it'll find whatever instance of that is attached to this object, and it will cache that for us there for reference. And we'll see where we'll need reference for that later on. We do not need an update method in here. However, we are going to have a method that we can call on the agent to tell it to move to a new position. So once we've calculated the position through our flock behaviors, we can have the flock agent move. So we're going to delete update, and we're going to say public void move, and this is going to autocorrect for me first. This is going to take in, though, a vector2, and I'm just going to call this velocity. It's not exactly the most accurate name for it, but it's sort of the offset position that it's going to be moving to, so it works well enough for our purposes. And we're going to do two things inside of this method. We're going to turn our agent so that it faces the direction that it's going to be moving toward, and then it's going to actually physically move it to that position. So we'll say transform.up equals velocity. And so this is because our sprite is the front of it points upward. It means that now whatever angle this velocity is at, the upward point will be pointing in that direction. If you're doing this with 3D, you would probably be doing this with transform.forward instead of up. And then transform.position is going to equal velocity times time.delta time. And we're just doing this to ensure that we have constant movement regardless of frame rate. However, there is a little bit of an issue here, not just my spelling error, but that right now there's a little bit of ambiguity between whether velocity here is a vector2 and this is a vector3, and so sometimes this will throw an error. We can avoid that simply by ensuring that we cast our velocity to a vector3 here. It might be a non-issue. Especially because what we need to do here is we're not setting it specifically to the velocity, but we're adding it to our position. So once we're doing this, we definitely need to make sure, if I was to delete this here, yeah, we see that we get this ambiguity because we're trying to add together a vector2 and a vector3. So we just make sure that we're, at this point here, we're treating these both as vector3s, because ultimately that's the struct that the transform is working with. So that's everything that we need inside of our flock agent. So now we can go back and actually create our prefab for this flock agent. So let's jump back over to Unity. What we're going to do is inside of our sample scene here, we're going to create an empty object, and I'm going to call this flock agent. And I'm going to add a couple of components here. Now, if I try first right now to add flock agent, it's actually going to not be happy with me. If I do this, you see it failed because it needs some sort of collider2D. But there are a large number of possible collider2Ds, so Unity can't decide, oh, I'll just add a capsule collider or a circle collider or whatever. We need to make that decision first. So the first thing we'll do here is add component. I'm going to add a circle collider2D, and then I can add the flock agent to this object. Now we also want the visualization. We want that sprite attached. So what I'm going to do is I'm going to right-click here and say 2D object sprite. And this creates a sprite object as a child that has the sprite renderer already attached. I'm going to rename this to flock agent sprite. And in our image here, I'm going to choose the flock agent sprite that we just created. And so now we see that appears on the screen here for us. The reason I'm creating this in a separate object is that I want to be able to potentially, I might need to say scale this sprite or something. And I don't want that to affect the actual kind of physical and kind of programmatic construction of the agent itself. So I'm kind of keeping that decoupled from the core flock agent. However, the last thing I do want to do is if I zoom in here, get rid of that camera, we see that this collider is actually really big compared to the sprite itself. So I'm just going to simply reduce the radius down a little bit so that it's a little bit more accurate to the size of the sprite. Okay, that's all we need for the flock agent. I'm going to quickly save the scene, and I'm going to add this flock agent to our assets as a prefab. So I'll drag this down in here, and now it appears as the prefab. I'm going to delete the prefab from the scene, because we are going to actually add those in programmatically, and I'll save the scene once more. So the last thing that we have to work on now is our flock. This is probably the most complex of the classes we're going to work on today, and that's because the flock really is pulling double duty in this case. It's going to both be responsible for populating the flock with our prefabs, as well as then handling the iteration and kind of executing the behaviors on the flock agents as they are iterated through. So today we're going to start with just kind of the setup, the instantiating of the prefabs, and getting all of our variables set up. So let's open up flock in Visual Studio. And in here, we're going to create, first off, the kind of handling the prefabs and the initial setup variables. So we're going to say public flock agent prefab. And this is where we're going to actually be able to manually put in that prefab to be populated. And then we're going to have a list of flock agents called agents. And this is we're going to automatically set this equal to a new list flock agent. And so this is just an empty list, and so once the flock starts populating itself, it's going to cache all of the agents in here so that it can iterate through them. And then we're going to have a public flock behavior, which is going to be where we can actually put in the scriptable object behavior that we eventually create. We're only going to have one slot for this because remember, we're going to create that composite behavior, which was what's going to actually allow us to go through multiple behaviors that are weighted differently and give us all that control. That's all going to be handled within a scriptable object. So all we have to do here is pass in one object that's going to take care of all of that for us. Next thing we're going to choose is how many agents do we want to create in the scene. For this, I'm going to put in a range just so that we have an easy slider we can work with. I'm going to say a range between, let's say, 10 and 500. And this is going to be a public integer. We'll call this starting size, or starting count maybe. And we'll set that by default to like 250. I'm also going to add a constant integer here, which is really just going to be, because of the way that I populate my initial flock, is I'm going to be populating it randomly within a circle. And I want to choose the size of that circle based on the number of agents that are in the flock. And so I'm just going to create a constant float here. Oops. A constant float, which is going to be called the agent density. I'm going to set that equal to 0.08f, and we'll see why that's set the way it is when we get into populating our flock. The rest of the variables that we need actually have to do with how the flock behaves and how fast agents can move, things like that. And so each of these is going to have a range attached to it. So again, we can adjust these as we want to, but still have some control over it. So the first one is going to be what's called the drive factor. And this is basically going to establish when you have these different behaviors, a lot of them actually are pretty either very small movements or kind of counteracting movements, so that you're going to get very slow movement of your agents. And so the drive factor is simply a way that we can kind of multiply and make our agents move a little bit faster. So I'm going to have a range here between, we'll say, 1f and 100f. So at 1f, it would just be moving at the default range, or at the default rate, rather. But at 100, obviously, these agents would be moving 100 times faster. And so we'll call this public float drive factor, and we'll set that by default to 10. Next, we're going to do another float between 1 and 100. This one's going to be the maximum speed. Even though we're multiplying the kind of calculated movement by a certain speed, we don't necessarily want to exceed a certain amount of speed. So we're going to kind of create a cap, which is going to be a public float max speed, which we'll set to 5. The next two are going to be how we calculate which either objects or our neighbors are actually count as neighbors for the purposes of calculating our behaviors. And so we're going to create two radiuses. The first one is going to be directly the radius for our neighbors, and then the second one is going to be a multiplier to say how much smaller is the radius for the avoidance. So we'll say range 1f to 10f will be our public float. We'll call this neighbor radius. We might use this for things other than neighbors too, like I said before, like obstacles, but for now neighbor radius makes sense. And then we'll have a range between 0f and 1f, and this is going to be our public float avoidance radius multiplier. And so this is always going to be, this way we know it's always going to be some value between 0, if there's no avoidance radius, to exactly the same as our neighbor radius. And we'll start with 0.5 for that, but we can again adjust that as we want to. Lastly, we have a few variables that are things that we're not going to set, but that we're going to use as kind of utility variables based on things like our max speed and our neighbor radius. But that's going to save us from having to do some excessive math when we're running our behaviors. So the first one is going to be float square max speed. And then we're going to have a float called square neighbor radius. And finally a float square avoidance radius. And I happen to know that the avoidance one in particular we're going to need access to, so I'm going to create another accessor in here. We're going to say public float square avoidance radius. And that is simply going to get and return the square avoidance radius. Now, obviously, we haven't calculated these yet. We're going to need to do that inside of our start method, and that's the first thing we'll do in here. So for each of these, what we're simply going to do is get the square of max speed, the square of neighbor radius, square of avoidance radius. And the reason that we're doing that is that when we're calculating, a lot of times we're just comparing, say, our current velocity against, say, our max speed. And to do that in Unity, there's a thing called a vector's magnitude. And if you get the magnitude itself, you have to do some square rooting, which is a more complex operation in a computer. And so rather than running square roots every time, we're just going to compare the squares against each other and save ourselves a step of math. So what we'll do here is we'll say square max speed equals max speed times max speed. We'll say square neighbor radius equals neighbor radius times neighbor radius. And lastly, we'll say square avoidance radius equals our square neighbor radius that we just calculated times the avoidance radius multiplier times the avoidance radius multiplier. And so again, those are just some utility things. We'll see them crop up as we continue our coding. From there, we can actually initialize and instantiate our flock. And so we'll do this using a simple for loop. We'll say for int I equals 0. I is less than our starting count. And then I++. So we'll do this a number of times equal to the starting count. And what we're going to do is we're going to create a flock agent called new agent equal to, and we'll call the instantiate method. And we're going to have a few parameters in here. So I'm actually going to break this into a few separate lines, its own block here. So the first thing we're going to do, the object that we're actually instantiating is the agent prefab. And then we're going to instantiate that at a random point within a circle. So we're going to say the position of this is going to be random.inside unit circle times the starting count of our flock times that agent density constant. And so this is going to say now that this is going to set that the size of this circle is kind of, like I say again, based on the number of agents that we have in the flock so that we always have a good density. They're not going to be so far apart that they're all flying away from each other or so close that they're all on top of each other. Next, we're going to set the rotation, and this is going to be some random value between 0 and 360 rotated on its z-axis, so it's kind of spinning in some direction like a clock. So we'll see here, we're just going to do this. It takes in a quaternion, so we're going to create a random vector 3 between 0 and 360, and then convert it to a quaternion. So we'll say quaternion.Euler, and we'll pass in a vector 3 dot forward, which is 0, 0, and then 1 on the z-axis, times random dot range between 0 and 360. And so that value will then get converted to a quaternion. That'll be the rotation. And lastly, we want to set the parent as well here. So we will say parent is going to be this flock itself, or more specifically, this flock's transform. So we'll simply refer to our transform. With that, we can give the new agent a name. We're going to say new agent dot name equals agent plus I, just so that we can keep track of which agent is which. And then finally, we'll add to our agents list. We'll say agents.add our new agent, so that we're keeping track of those and we can iterate through them. So that's all we need to initially set up our flock. We can jump back over to Unity and create a new flock object. So we're going to right-click, create an empty, call this flock. I'm going to reset this transform. And actually, while I'm thinking of that, I'm actually going to jump to the flock agent prefab. Okay, I think probably because it's a prefab, the transform position doesn't actually, it's already set to 0, 0, 0, but just wanted to double check that. Typically that shouldn't matter, the prefab's position, because it's going to be instantiated, but just to make sure that we're not having any weird effects. Okay, so we've got our flock object. Its transform is reset, and I'm going to add the flock component to that. So we see we have all of our settings down here. We've also got our space for our prefab, as well as for our behavior. We don't have any behaviors we can add yet, but we can add the agent prefab as the prefab there, and actually now we have everything we need to kind of kick off this flock and at least populate it into our scene. So if I save my scene and hit play, we should see that our circle here, we get a nice circle full of these flock agents. Now they're not doing anything because we haven't started our behaviors or populating through them yet, but this gives us the start of the flock that is going to now be able to start, each of these agents is going to be able to start evaluating the neighbors around it and moving and start moving in this sort of what appears to be a coordinated flock movement. We'll get started into that in the next video. In the meantime, as always, like and subscribe for more videos or consider supporting on Patreon. And thanks so much for watching, and I'll see you next time.